Lesson 4.8, solving problems with trigonometry. So we're going to use sine, cosine, and tangent, creating right triangles to solve different story problems. Before we go through some examples, we need to understand the difference between angle of elevation and angle of depression. So if we're looking horizontally and the reference we're making, that angle is going up, that's the angle of elevation. If we're looking horizontally and the angle we're using as our reference is going down, that's angle of depression. Example 1, suppose a battleship detects a fighter. Example 2, from the top of a 100-foot tall building, a man observes a car moving toward the building. If the angle of depression of the car changes from 22 degrees to 46 degrees during the period of observation, how far does the car travel? In this problem, we're going to have to set up two different equations to solve in order to find this distance x. The first distance we need to find is the distance from D. So the distance from the base of the building to where the car ends up during the second observation. So we need to set up another trig function to find that distance D. We have our angle, we have the opposite side, we're looking for the adjacent, so we need to use tangent. The equation we can set up is the tangent of 46 degrees is equal to 100 over D. Now it's going to be the same process we did in the last example to isolate it and get D by itself. So if you go through and solve for D, you get D as approximately 96.57 feet. Now we need to go through and solve for the length of the bottom that includes x plus D. So we use this large right triangle. Our angle is 22 degrees. We still know what the opposite side is, and we're trying to find the adjacent. So again, we're going to use tangent. So the equation we get is tangent of 22 degrees equals 100 over x plus D. Go through the same process we just did, isolate x plus D by itself. So if you go through and isolate for the quantity x plus D, that is approximately equal to 247.51 feet. Now we just need to take the distance we know for D from the previous part, which is 96.57, subtract that to the other side to isolate for x, because that's the distance we're looking for in this problem, the distance the car traveled between those two observations. So that distance ends up being approximately 150.94 feet. Before we get to the last example, we're going to quickly talk about Raven Industries, which is a company in Sioux Falls. They deal a lot with materials and engineering, and one of the things they do is make some of the balloons for the Macy's Thanksgiving Day Parade. So you can see some pictures. I believe these are some of the balloons they've made in the past. So in the last problem, we're going to incorporate and use SpongeBob. So example 3, suppose one of the balloons for the parade is connected by two cables that form angles of 40 and 50 degrees with the ground. If the cables are attached to the float 10 feet from each other, how high above the ground is the balloon? So again, just like the last problem, we're going to have to create two different problems in order to solve for the height. What we're going to do is create our two different equations and isolate the variable h by itself. So if we're using this smaller right triangle first that incorporates the 50-degree angle, we can take the tangent of 50 degrees is equal to h over x. So we have tangent of 50 degrees equals h over x. If we isolate h by itself, we would multiply x to the other side. So x times the tangent of 50 degrees equals h. Now we're going to set up another equation incorporating the 40-degree right triangle and solve to isolate h by itself. And if we do that, we get the quantity x plus 10 times the tangent of 40 degrees is equal to h. So since we have two equations that are both equal to h, we can use the substitution property and substitute this expression in for h in our other equation. So now instead of having two unknown values, we're only going to have one unknown value, x. So we get x times the tangent of 50 degrees equal to, how I got this part on the right, I just distributed these to the tangent of 40 degrees. So I have x times the tangent of 40 degrees and then 10 times the tangent of 40 degrees. If we're trying to solve for x, we want all of our terms that incorporate x on one side of the equation. So we're going to subtract x times the tangent of 40 degrees to the left side. Now if we look at both these terms, they have a factor of x in common, so we can bring that out in front. Now that we have x factored out in front, we can divide by the quantity of tangent of 50 minus the tangent of 40 degrees to get x isolated by itself. So now we get x equals 10 times the tangent of 40 degrees divided by the tangent of 50 degrees minus tangent of 40 degrees. So if you type this in a calculator, you get x is approximately 33.79. We're not quite done with the problem because that just represents this distance. Now we need to use that distance to find h by setting up another trig ratio. So we have our angle 50 degrees. We're looking for the opposite side. We know the adjacent, so we're going to use the tangent function. So we have the tangent of 50 degrees equals h over 33.79. To get h by itself, we would multiply 33.79 to the other side. So the tangent of 50 degrees times 33.79 is approximately 40.27. So the height of the balloon would be approximately 40.27 feet. Jet approaching its location, the plane is estimated to be 10,000 feet above the ground, and the angle of elevation from the battleship to the fighter jet is approximately 20 degrees. Find the distance a missile would travel if the crew were required to take down the fighter jet at this time. So if we look at our sketch to the right, we have a right triangle that is created. We have our angle of elevation, which is 20 degrees. We know the opposite side, which represents the height of the fighter jet, is 10,000 feet. And we're looking for the distance from the battleship to the fighter jet. So in this right triangle, we're looking for the hypotenuse. So we have our angle. We know what the opposite is. We're trying to find the hypotenuse, so we're going to have to use the sine function. Recall SOHCAHTOA, sine is opposite over hypotenuse. So the equation we set up is the sine of 20 degrees is equal to 10,000 over x. If we want to solve for x, we need to get it out of the denominator of this fraction, so we multiply x to both sides of the equation. Now if we want to get x isolated by itself, we need to divide by the sine of 20 degrees. And then if you take 10,000 divided by the sine of 20 degrees, you get approximately 29,238 feet. And if you wanted to put this into a better perspective, you could convert this to miles by dividing by 5,280 feet, which you would get is approximately 5.5 miles. So that is the distance that missile would have to launch from the battleship to the fighter jet.